So this was a concrete example. Now let's consider the set of all vectors W which are linear combinations of some subspace. This is W of V, and we consider this set and subspace spanned by this set. Now how do we show that this indeed is a subspace? All the linear combinations of the set will actually be a subspace W of V. How do we show? Well, if W and W prime are two vectors, small w and small w prime are two vectors, then so is also element of the same subspace. And I'll also have the zero vector, which is going to be 0 v1 plus 0 v2 0 vn. I can express zero vector also as a linear combination, and that's also going to be a subspace. That is also going to lie in W. So indeed W is closed under addition, and 0 is an element of W. So that makes W a subspace. So the bottom line is that I give you a set of vectors, and all the linear combinations indeed form a subspace W of the original vector space V, and we just showed it, that it's closed under addition and 0 is part of the subspace over here. So just that the space spanned by a set S is denoted by span S